Welcome to qnawire.
Hi, so unfortunately for this question, no more information is provided. So the possible questions that could come up from here are of two types. One would be calculate the delta G of the reaction that gives free energy for the reaction, because we know that the gives free energy is equal to delta H of my reaction minus 2 times delta S for the reaction. So we can calculate delta G naught of the reaction that we have. The other type of question that we could have with the information that you have provided would be to apply Hess law in order to know the delta H of formation for a particular element that we have. So for this reaction, for example, we know that delta H of the reaction is going to be equal to delta H naught of formation of B as a gas plus delta H naught of formation of C as a gas minus delta H naught of formation of A as a gas. So, for example, if they provide to you the heats of formation for A and C, one possible question would be now calculate the delta H formation for B. The other type of question would be essentially the same thing but with delta G's. And the formulas are going to be almost the same, right? Remember that the delta G for the reaction can be written in terms of the formation energies by adding up all of their products and subtracting the formation energies for the reactants. So those are the three puzzle questions. Just for exemplifying this one over here, we know that delta H of reaction is equal to 39.8 kilojoules per mole. We know that delta S of the reaction is equal to 81.3 kilojoules per mole. So let's say that we're working at a temperature equal to 298 Kelvin, that is the standard temperature. So the delta G for the reaction in that case would be delta H minus T delta S, that is 39.8 kilojoules. Oh, sorry. Here the delta S of the reaction is given to you in joules per mole. So we should do the calculation with everything in joules per mole and then turning back to kilojoules per mole. So in order to convert this to joules, we can simply multiply by times 10 to the 3 joules per mole minus the temperature. In this case, I am assuming 298 Kelvin times delta S, that is 81 81.3 joules per mole Kelvin. Remember, entropies are always going to have units that resemble the ones for the gas constant. And after this calculation, the delta G for this particular reaction at 298 Kelvin would be 15,572.6 joules per mole, or rounding up, this is approximately 15.6 kilojoules per mole for delta G of the reaction. And that would be all. Thank you very much.